For our first IB lab write-up, we're going to investigate how the incline of a ramp, how steep a ramp is, will affect the acceleration of a cart that rolls down the ramp. Now, in IB, we have, whenever we write labs, we always have to write up about the design. We have to collect data and process it, and then we have to write a conclusion. This lab in particular, we're only going to grade you on the conclusion. We'll grade you on the other stuff, just getting it done, but the main part we're grading is the conclusion writing. So that means, since we're not grading you on the design or the data processing and collection, we can do that all together as a class. We can write the design and collect data together. So, in order to write the design, I'm going to have you guys write your design at home and to the best of your ability, and then the next time we meet, we will discuss your design and how we can improve it. And then we'll collect the data, and I'll help you with how to write conclusions, and you will then go do the conclusion, or write up the conclusion on your own. But before we can design a lab, we have to understand exactly what we are doing and how the equipment is set up. So I've taken a picture here of the setup of the equipment. Again, we're investigating how does the incline of a ramp affect the acceleration of a cart as it rolls down the ramp. So our ramp is here, right? We're going to stack it up with books and increase that incline by putting more books up. We are going to then just roll it down and measure the acceleration and change the incline and see how that affects it. In your actual design worksheet that you have to fill out, there are several components that they want you to answer. The question, which we've already given you, how does the incline of a ramp affect the acceleration of a cart moving down that ramp? And then they also want you to state your hypothesis, so you're going to do that yourself. What do you think will happen as the incline gets greater? What do you think will happen to the acceleration, or something like that? You're going to state the experimental condition. This is confusing for a lot of people. All this is it's just a quick summary of how you're going to go about it, right? So we're going to go about this by setting up a track on a table and increasing the incline with books underneath and rolling carts down and measuring the acceleration with a device called a motion detector. That's the experimental setup. I just explained that, or this experimental condition. You have to decide from the question what is the manipulated variable, the variable you are changing and manipulating. What is the responding variable, the thing that will respond after you make your changes. And what variables you need to control. And you have to decide what variables are the ones that you think are most important to control. I won't tell you what they are. You figure it out. We'll discuss it in class. The other thing that a lot of people forget or don't understand is the prediction is slightly different than the hypothesis. The hypothesis answers the question in general. The prediction answers the same question but specific to the experimental condition. So for example, while your hypothesis may say something like, I think as the incline gets steeper, the cart will accelerate at slower rates or lower rates. So as the incline goes up, the acceleration goes down. If that's your hypothesis, fine. But the prediction would say something according to the experimental condition. So something according to the actual lab setup. So it would say something like, as I put more books underneath this ramp, I will notice that the cart will accelerate at a greater rate, at a lower rate. This means that I should notice that it'll take slower to get down the ramp at a steeper angles or something like that. So notice it's specific to the actual setup. Materials and illustration, just list what materials you think you're going to be using and then draw a quick picture. And then finally the procedure, the big one. The main thing in any design is to write out clearly in the procedure how you will measure your manipulated variable. I need that very clearly stated. What are you going to do to measure your manipulated variable? What are you going to do to measure your responding variable? And what are you going to do to control the variables that need to be controlled? That's the main thing that belongs in a procedure. Those are the things that I'm looking for. You can also put in exactly how you set up, and those things are important as well. But the main thing I'm always looking for is how did you manipulate your manipulated variable? What did you do to measure your manipulated variable, to measure your responding variable, and to control your control variables? So in order to write your actual procedure, you need to know a little bit more about how your equipment works so you can describe what it is that you're going to do in the lab. So let me explain how this setup works. First of all, how are you going to measure your manipulated variable, the incline? That's a little bit of a vague term. Sometimes people interpret incline as the angle that the ramp makes with the table, something like this. And that is the incline. That is one way to think of that, about an incline, is the angle that it makes. Some other people like to think of the incline as how high the books are. If the books are taller, then the incline is steeper. This is also true, and they're both correct ways to measure incline, because incline is just a general term, a vague term. However, in this particular experiment, we're going to measure the incline in a slightly different way. And just like measuring the angle or measuring the height of the books, it does the same thing, and it will give a unique value for each steepness. And the reason we're going to choose this other method is because it'll turn out to be useful as we're doing our conclusion. And I'm making you do it because I know that it'll be useful. Okay. So what we're going to do is we're actually going to, instead of using the height of the books or the angle right down here, we're actually going to use the sine of this angle down here. So if we put both of those together, so we have this little triangle here, right? And it's a right triangle, even though this looks slanted. This is a right angle right here. So this is a right angle here, and we have a nice right triangle, and we can say if each angle, as you get more and more books up, and the angles get steeper and steeper and steeper, as you have each unique angle has a unique sine of the angle. Okay, like if you type in sine and punch in the value for the angle. So if you'll remember right, we calculate sine by just doing opposite over hypotenuse, right? So in order to actually measure the incline, which will be the sine of this angle down here, you actually just really need to measure the opposite side of this right triangle and the hypotenuse and divide the two. So the opposite side over here is the height of the books. So we are going to have to measure the height of the books. The hypotenuse is for lack of a better word, the length of the ramp. Now notice it's not actually the length of the entire ramp, but it's the length of the ramp within this triangle. So we're actually going to have to measure this distance here and the height of the books, and then you calculate sine of the angle by doing opposite or height of the books divided by the hypotenuse or length of this ramp. Now that we know how to measure the incline, we now need to know how to measure our responding variable, the acceleration of the cart. So I forgot to show you on the last slide, but there was a little green box right before the cart, right behind the cart. And that little green box is called a motion detector, and we'll use it in class, and you'll see that when you turn it on, it'll go click, 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 click. Okay? And so what you do is you go ahead and you push this, it'll be green in class, you push this collect button, and you let the cart roll down, and it'll go click, 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 and it'll record the motion, and it'll record where it is at different times, and it'll create a position versus time graph, and it'll create a velocity versus time graph as it speeds up down the cart. Now, which graph would we use to figure out the acceleration? The best one, of course, would be the velocity time graph, and all we need to do is to find the slope of this velocity time graph to find your acceleration. So in order to find the slope, you're going to do this in class. You're going to highlight, and again, I'm telling you this because you need to explain how you measure it in your procedure. You highlight the portion of the graph that looks like it's part of the motion. You can see here, right? I don't want to highlight that because that's before I let it go. I'm going to stay away from this edge just because maybe I give it a little push. So I'm going to highlight maybe from here out to, and I'm going to stop right here. Right here looks like I caught it or it fell off the track or whatever. And so this is not part of the motion I want. So I'm going to stay away from those two edges, highlight from here to here. And then you just come up and you click on this button right here, the R equals button, and it'll just tell you the slope of the line. The computer will calculate it for you. Now you can see I have done that, and it says right down here the slope. The slope is 0.6106 meters per second. So that is the slope or the acceleration of the cart.